Hello, and welcome to the 2021 Virtual Sea Scout Academy pre-recording. The actual class for this took place on October 19th from 1800 to 1845 Mountain Time. Today we're going to be talking about blocks and tackle, able requirement 6C. You can find this in your 2020 version of the Sea Scout Manual on pages 124 to 126. Hello, my name is Braley. I'm a Sea Scout from ship 3821 in Dunkirk, New York, the SSS Earn. I am an Eagle Scout, local camp staff, currently an ordinary Sea Scout, 2021 SEAL graduate, and previous Area 4 boatswain. So in this requirement, they're asking us to describe the parts of a block and explain how blocks are sized. Describe the following types of tackle: luff, gun, double purchase, single whip, and a runner. And with that knowledge, they want us to solve a real-life scenario where we save a shipmate and also learn some other techniques. So the first question, what is a block? So a block is basically a pulley. It's a combination of one more disc or sheaves, and we're using these to reverse the direction. So if you look at the single block, we have on this left side, if we were to pull down, which way would the force go? On this right side, well, we're going to be the force is going to be applied upward, so in the opposite direction. And then when we combine these, we also get a mechanical advantage. Now we're going to be talking about that later in tackle systems. So the first type of block we have is a single block. A single block has one single sheave and is the basic building block of tackle systems. Then we go on to the double block, and it looks just like like two single blocks put together. Well, when we have a system of blocks, and we have a lot of mechanical advantage that we need to get out of them, we'll often have a row of single blocks that in this vast movement, they'll be knocking against each other. Well, that causes a lot of wear, and when we need to go and do repairs, it can be really complicated looking at all these blocks, so we just put them on one axle in a double axle. The next block is a runner block, and it doesn't change the direction of the line or the force being applied, but I've been told on sailboats it's used to redirect or pull the line away from specific areas, especially for safety concerns, or maybe there's already lines there. And then the last block which I find the most interesting is a snatch block. This is a block which the faces or shells are disconnected, and you're able to open them up and quickly create a system or add this to a line that's already under tension. The one disadvantage of a snatch block is they often don't have, because they're open face, they don't have a hook built in, so you have to bring with you carabiners to hook these together. So the parts of a block start with the sheave. Now the sheave is the part that the line is able to run over. Now if we didn't have the sheave, we just have the line running over an axle, which if you've ever had rope burn, just tears up the line instead of your finger in rope burn case. So the sheave is very important. After that, we have the breech. So the breech is where the line comes in and enters the block. If you don't have a breech, you just have a block of wood. Then we have the shell. Now the shell is what contains both the line and the sheave from falling to the other side. Then we have the hook eye or shackle. This is what allows you to put your block in context of other objects. They say that if your block doesn't actually have, if you know that there will be a point where it doesn't have tension on it, you should do what's called mousing the hook, which is where you go from the tip to the other side and you run wire or rope between it. This is kind of like in a carabiner, or some blocks already have it, where a little bit of metal is with a spring and that keeps it closed. So that when if you do lose tension on your block, then you don't lose your entire block out of the system. Next, we have a tally plate, which isn't in this diagram, but that's the plate that would be nailed on the side. It would let you know the maximum handle weight that the block can handle. If you go above this, you may bend your hook or actually break your sheaves. Be really nasty and also very dangerous. After that, we have the swallow. Now, the swallow, we talked about the breech is where the line enters. The swallow is where the line runs through. So this is actually a vacant spot. We need to keep that vacant by making sure the line is the right size and we size our block properly. Also, we need to make sure that we don't have any knots in our line. If you have a line that's running really fast with a lot of force on it and you put a knot in it, it comes through the shallow and just rips apart the block. We don't want that happening at all. Next, we have the pin, which is actually the rod that we're inserting into the block, which serves as our axle for the sheave. So I talked about with the swallow, we need to size our blocks properly. So how do we do that? Well, the first step is you actually want to measure the circumference of your line. So if we're looking at a cross section of our line, like it's going in and out of the page, we're going to take a small rope, wrap it around the side, and then lay it out over a ruler. And that's going to be our circumference. Now, we take that, multiply that by 3, and we get how big our shell should be. Multiply that by 2, and we get how big our sheave should be. So if you see here, this would be like the sheave is 2, and your shell is the 3. So 3 minus 2, we get 1. Well, 1 is going to be the size of our line. So you'd have a shell on the other side of your sheave, and that would then encase the whole system. So I've mentioned tackle systems quite a bit in this, and now we get to talk about them. So what is a tackle system? So tackle is when you take multiple blocks and we're putting them together so that we can get more work out on the other side with putting in less force. So this is the concept of mechanical advantage, where we're having a ratio between our input and our output force. So for example, I have a system with a mechanical advantage of 1 to 2, or 2. So I put in 100 pounds, I'm going to get out 200 pounds. So if I put in 200 pounds now, same system, how many pounds do you think I'm going to get out? Well, I'm going to be getting out 400 pounds. Now, in the world of tackle, lunch isn't free, so we have a little bit of friction working against us. So in order to calculate that, we're going to be using these letters to represent some variables, and we'll have MA being our mechanical advantage, W being our weight, TW, like TW Cook, being our total weight. So that's going to be the weight plus our friction that we're going to be having to deal with. Then we have L being the lines not reeved. So those are the lines that you aren't actually pulling on, but they're still moving. Then we're going to have F being the friction efficiency. And in order to find that, we're going to take the L, the number of, we're going to be taking a number of sheaves, so the part that rotates, and we're going to be multiplying that by 0.1. So I have a little demonstration here, which describes a little bit more about mechanical advantage. So we're going to start this about 3:04.
Up and generate a model of how we were picking up those cinder blocks. When I pull on this rope, that tension transmits itself all the way through the rope to the very end. Wherever the rope is, there's also tension. If I pull here, think about the word pulley. It pulls on the rope on the other side of the pulley, right there. That pulls on the rope there at the bottom, which then pulls on the rope on the other side of that pulley, which ultimately pulls against that hook at the very end. All of the ropes are in tension. Now, if you look down there at the cinder block, you'll notice that there are 2 arrows pulling up on that pulley. That's why we get twice the force on the cinder blocks. But what if we want to pull harder? Can we just add more ropes and tension? Yes, we can, using this. It's basically a double pulley. Some people call this a block and tackle. Instead of 2 ropes pulling down here, we get 4. Just a little bit of force here, even with my pinky finger, that's like 10 pounds of force by just barely pulling at all. This is the same number of ropes and like pulleys and everything. It's just flattened out so we can see what's going on. So I've got a scale. I'm going to attach a scale to the input of the rope. And remember, if we put input tension, that tension goes all the way through. So as I pull here, I have 1, 2, 3, 4 ropes connected to the thing we're pulling. So if I put 2 pounds here, look at that. I get 8 pounds on the output. That's awesome. I'm getting 4 times the force, but I'm only moving it 1/4 as far. How far do you think we can go with this? You think we can double it again? So now we have 2 blocks with 4 pulleys each, which if you count all those up, 1, 2, 3, 4, 5, 6, 7, 8, we have 8 ropes in tension on that block. So as I pull here, look at this. That's nuts. That is a little bit of force and a lot of output. That is some serious mechanical advantage. Look at this though. The ropes over close to me are moving a lot, but the ones over near you aren't moving as much. Let's break this thing apart again and see if we can understand what's happening. This is so awesome. Oh man, that's a great shot. Okay, so here's what we got. We've got 1 input pulley. Let's count off the tension again. 1, 2, 3, 4, 5, 6, 7, 8. I put 2 pounds here on the input. That is a lot of force on the output. Remember on the block and tackle, the ropes were moving at different rates. Well, think about this. On this side over here, that rope is tied up there. It's not going to move. On this side, I'm pulling the rope. It has to move as much as I pull it. And the same is true for this one because it's just redirecting that string. But after that, everything is affected by how much this moves. So just playing around with it here, you can see that these ropes move a whole lot more than that one over there that doesn't move at all. There's a lot going on here. Now, this is the sort of thing that, yes, you can probably explain it with words, but if you have a fundamental understanding of how this stuff works, and you just know how to use it to your advantage, you can get yourself out of some really interesting situations. For example, the other...
Okay, so I hope you're paying attention to the last system, and how many lines did it have, and what do you think the mechanical advantage of it was? So, I hope you got the right answer. It was 8. Okay. So, you saw as in the demonstration, you kept adding more blocks to the system and increasing the mechanical advantage. Well, as we increase our numbers of blocks, we give each of those steps a name. So, the first one is called a single whip. This is when we have one block, it's attached to a stationary object, and we're getting no mechanical advantage, but we are reversing the direction. Then we go and have a runner, which instead of the whipping the block being stationary, we're making the line stationary, and the block is moving. Now in a runner, there is no mechanical advantage, and the block moves in the same direction. Now that sounds kind of weird and almost useless, but when we put a single whip and a runner together, we get a gun tackle. Gun tackles were originally used to move the cannons under a ship. So you'd have several guys pulling down, reeving on that line, and they get a mechanical advantage of 2 out. So it would be almost like having double the amount of people helping them move it up. Then, as we replace one of our blocks with a double sheave, then we get what's called a luff tackle, and we're increasing the mechanical advantage. The luff tackle is considered one of the most useful forms of tackle. Then we increase complexity, we increase mechanical advantage, we get a twofold or double purchase tackle. Instead of just having one single sheave and a double sheave like a luff tackle, we have 2 double sheave blocks in a twofold or double purchase tackle. So if you notice, we go from single whips to twofold or double purchase tackle. We're increasing in both number of blocks, complexity, and mechanical advantage. So here's a quick image. It shows all of them put together. And let's figure out the mechanical advantage of each of these. So we have a single whip. What do you think that is? Well, we have one line that's not being reeved, so that's 1. Gun tackle, that's going to be 2. Luff tackle, 3. Twofold purchase, we have 1, 2, 3. We have 4 lines, so that's going to be 4. and so on. So let's look at a threefold purchase. Wow. And say we have an input of 100 pounds. What's our mechanical advantage? So we have 1, 2, 3. 1, 2, 3, 4, 5, 6. Okay, so we have 6 unreeved lines and 1 being reeved. So we have mechanical advantage 6. Multiply that by 100 pounds. We have 600 pounds of output force. So with only 100 pounds input, so that'd be like taking a medium-sized adolescent, having them hold on and just drop their weight. They could pick up 300-pound people. That's incredible. Now there's going to be I said in the roll of tackle, there are no free lunches. So we have friction involved here. So let's figure out how friction changes this. So there's an equation that goes with this. The total weight that we'll be experiencing is equal to the weight that we're applying, that we have, times 1 plus the frequency of the friction efficiency. So in order to find the friction efficiency, remember that's the number of sheaves, the part that spins, times 0.1. So let's take the gun tackle as an example. We'll do this together. So we start off, we have 2 sheaves here. Okay, so our F is going to be 2 times 0.1. So we have 0.2. Now we're going to add that to 1. Now we have 1.2. Then we're going to multiply 1.2 times 100 pounds, which we then get 120 pounds. So what does this mean? This means that if we were to originally apply it, this has a mechanical advantage of 2. We apply 100 pounds input, we get 200 pounds output. Well, in order to still get those 200 pounds output, we now have to apply 120 pounds instead of 100 pounds. So now I'll have you try a double F on your own. Actually, go do a twofold purchase. It's a little easier. Okay, so now that you've finished, cut that out. Cut that out, Braylee, please. Okay, now time for the scenario. So, you and another scout were whitewater rafting. Sounds so much fun. But then the rapids flipped your raft. Oh no! And after a swim, you've reached land. However, your friend and raft are still stuck on the rock, and you must now bring them to shore. So, as a group, or now pause the video and plan how you're going to rescue your friend using block and tackle systems. Okay? So here comes the solutions. So this first one is going to be how you set up the whole system, and then after that we're going to see how one of the parts functions.
All right, for a simple mechanical advantage system, we're going to start with attaching the end of our rope to our load. Then we're going to bring it back to shore and put it through our first pulley. And we're going to attach our pressic back to the same carabiner that this pulley is attached to. Ideally, this would be about 1 hand width away from the pulley so that it's not too long. Right now we have a 1-to-1 relationship with the change in direction. If we want to make this into a 3-to-1 system, we'll take another pulley and we'll attach another pressic out here towards our load.
One thing I would like to note at this point, see right here where there's where he's tied a knot. This actually is what the next video covers. So pay attention to how that functions when he starts using this.
We now have 1, 2, 3 tension lines pulling on one, so we have a 3-to-1 mechanical advantage system. When I pull with 1 unit of force, the boat feels 3 units of force. Right now, though, if I pull and something breaks, this pulley will come and hit me. And so I'm kind of in an impact zone, and in order to get out of the impact zone, what I could do is attach one more pulley in here
Notice he's using a snatch block.
And this gives me a simple 3-to-1 mechanical advantage system with a change in direction at the end. And this pressing here acting as a progress capture device. And we could pull from way out over here, out of the way, outside of the impact zone.
Okay, so we talked about...
Get even more pulling power, we could switch this to a simple 5-to-1 mechanical advantage system by adding one more pulley over here. Now we've got a simple 5-to-1 mechanical advantage system with 5 tension lines, 1, 2, 3, 4, 5, to 1. But again, we're inside of the impact zone right now. So in order to fix that, we add one more pulley. And now we have a simple 5-to-1 mechanical advantage system with a change in direction, so again we can pull from outside the impact zone.
Cool.
Alright, so to change our 5-to-1 mechanical advantage system into a compound 9-to-1 system, what we're going to do is find the third line, the one that we would pull on in order to have a 3-to-1 system over here. And we're going to attach one more pressic to this line. So, attach one more pressic on here. 1, 2, 3. So now what I'm going to do is detach my last pulley from over here. And attach it in over here. And now you'll see that we have a simple 3-to-1, pulling on another 3-to-1, which gives us a total of a compound 9-to-1 mechanical advantage system. And again, our final pulley acts as a change of direction so that we could pull from outside of the impact zone.
Okay, so that showed you the setup that you would use to solve this. This is what we call a Z-drag. So I hope you're paying attention. If you need to, this is the link so you can go back, and when you do this for your skipper, you can plan it out ahead of time. This is a great video. I go back to it every time. So he did mention what's called a progress capture, and that was the knot they tied. And this video will help explain kind of how that works and more of what it's supposed to do.
I'm going to use my 8mm rope. And why am I going to use my 8mm? Because rule of thumb, when you're sizing pressics to the rope, says that your pressic needs to be 50 to 75% of the size of the rope that you're working with. Okay, so I have this 13mm rope, and I have an 8mm pressic. So let's go ahead and install this pressic. Really easy to do. There's several different ways to tie it. The way I'm going to tie it today is very simple. I think it's the simplest. It's called a 3-wrap pressic. So I wrap the pressic around the rope, and I'll take the loop that's not stitched, and I'll take the stitched end and pass it through 3 times. Wrap it back around the rope. So that's 1. There's 2. 1 more wrap to make 3. Again, back through the loop of that rope with the stitched end. And as I come back through, I want to make sure that my loops don't jump over the top of each other. You call them buttons or loops, kind of like an aluminum tie. You want to make sure that your buttons don't jump over each other. Okay, now that's called dressing it to make sure it's all set just right. Kind of pull it tight on there. So now, look at that, it holds on the rope. I can pull up, I can pull down. Now what I've done here is I've attached it to this line that has a load on it. So I want to slide this down. Now I'm going to attach it to my anchor point. See, this stitched end is going to my anchor point. Okay, looks good, still dressed out nice. Okay, here's where the pressic-minded feature of the faceplate works with the pressic. As I pull up on this load, you see that the faceplate doesn't allow the pressic to go up into the block, get sucked into the block. So when I release, the pressic grabs the rope, holds onto my load. So as I lift the load and I let go, it holds the load for me. So that's called progress capture. Is I make progress with my load, bring it in a direction, and then release it, it captures the progress that I made. Now to release that, very simply, is I just can take a little tension off the load, slide up underneath the pressic, and lower my load down. That releases the pressic. As soon as I don't want the load to be released anymore, I let go of it, and it sets itself. Okay, so let's see where there are applications we could use this in. Obviously, this is a very simple system. Let's go over here and take a look at this. Right here, I have a set of 4s. I'm going to hang a transformer. Could be in the backyard, wherever. I have a set of 4s. I have my pressic attached right here with the super cool side swivel pulley with that faceplate, right? That pressic-mounted faceplate. So again, as I lift up this transformer, this is about a 300-pound transformer. So I lift this up. My pressic is sliding down because the side swivel pulley is keeping it down there, right, on my load line. And as I release, my pressic grabs. So this is really good. It's ergonomic, right? I mean, if I go ahead and have one guy down at the bottom of the pole, you don't have to support that load with one hand every time. You can just grab this load, bend your knees, come back, release the load, come back up, and grab another purchase right there. Okay, so let's say the transformer's up in the air. It's up to the lineman. He wants to hang it on the bolts. All you have to do is just pick the load up a little bit. The lineman can reach underneath that pressic and lower it down and hang it right on the bolts. So this is just one application you can use it in. There's several more. So it's a great system, great design on the side swivel pulley.
Awesome. So now with your cunning Z-Strike system and newfound knowledge of block and tackle, you have saved your friend and gone on your way to earning the able 6C requirement. Congratulations. You will still need to demonstrate this specific scenario to your skipper, but thank you for joining us for the 2021 Virtual Sea Scout Academy in this after recording. Hope you have a great day. Fair winds and following seas.